Today let's go over a medium grind 75 question. This one I solved over half a year ago, and it's called combination sum. You may know this as a backtracking question, but I want to show you another way to solve it using different techniques. So you can see that the constraints are relatively small, so we can probably do this in a more intuitive way, which I'm going to show you. So we're given an array of integers. They're already distinct, so that's great. And another target, and you want to return a unique list of combinations from this list where the chosen numbers sum the target. And you can return them in any single order. And so, for example, if we have 2, 2, 3, we don't want to do 2, 3, 2 again because that counts as a duplicate based on the frequency. So, yeah. And in the case where there's nothing sums up the target, then we're just going to return an empty list. Again, here, we are going to append as many of the copies of the same element until it sums up to the target. So this is a backtracking question. It's similar to subsets, but I'm going to show you another way to do it, which is simply to use the combinations module in Python. So A in combinations, candidates, let's print A to C. Okay, so I guess we can also just iterate over the array. +1, because we're gonna need that. And let's do I, let's print A. Cool, so now if sum of A, right, so each length 1, length 2, combinations, length 3 combinations, length 4 combinations. That's why we're going to length of candidates +1, because Python only includes, is basically this value minus 1. So if sum of A is equal to target, print A. Okay, so I don't know why that's not giving me what I want. Okay, because the issue is you can repeat elements as well. So I guess backtracking is the way to do this time. So let's define a function, and let's pass in a variable called I, which is going to iterate over the list. And then right now we have our current sublist that we're going to clear if we break some conditions. So if we reach the end of the sublist, so if I is bigger than or equal to length of candidates, then we can just return, right? Or if sum of current is bigger than target, we can also return, right? If that's not the case, then current.append candidates of I, and we call this again I +1 because we go to the next element, or we stay on the same element until the sum exceeds, and it's called current. And then if the sum exceeds like 2, 2, 2, 2, then we pop, and then we try the next element over. So we're going to keep trying 2 until we get too big. 2, 2, 2, 2, and then we're going to pop and try 3. So if you can visualize it like a tree, that helps a lot. And then this is -1 because this is length, this is indexes. And if sum of currents is equal to target, then we can print current, right? Let's see what it looks like. And then we can also probably just return 2, 2, 3, but we're missing the 7. Okay. Okay. Let's call this self.results, self.result.append current, and return self.result. Let's make a copy of the current, so because we're going to keep modifying the list over and over again. Right, if you just don't do this, then you're going to get the modification, because we're going to pop from the same list, right? We're going to go 2, 2, 2, 2, pop 1, try another one, and then pop until we haven't visited, and then try 3, and then too big, pop again, and vice versa. That's going to keep getting bigger, and then eventually we're going to have 7, which should be added to the input array. So I'm not sure why that's not being added. So let's see. Cur.pop perhaps. If current.pop 223, but we're not getting 7. Let's print current to see what it looks like. It looks like we're getting a 6, but not the 7. Oh, if it's bigger than or equal to length of candidate, it's not the -1, because I is going to be like 2, but we're stopping it whenever it's even equal to 2. -1, which is 1, and that's not what we want. We want to get to the last element, right? So let's submit this, and there you go. So it works. This is a pretty common backtracking problem, and it's good to practice recursion because dynamic programming uses a lot of backtracking, and so it's definitely important to learn. It lays a solid foundation for choosing and not choosing different states, and so yeah, very important to learn. I hope this video was helpful, so thank you for watching.